Hey everybody, it's Mr. H. In this video, I'm going to talk about simplifying square roots. And just as a quick reminder, if you are one of my students, you should be taking notes on this, and I will be expecting you to turn in the notes to show me that you actually watched the video. To get our conversation started about simplifying square roots, I just want to kind of draw your attention to something that we've already talked about in the past to consider this. The square root of 36 is 6 because 6 times 6 equals 36, and that's all the work you would have to show. So like if I said, hey, simplify this, and I gave you square root of 36, you could just say it's 6. The reason why you're able to just jump to the answer is that 36 is a perfect square. And perfect squares, just as a quick refresher, are those numbers that you get when you multiply the same natural number together. Meaning in this case, 6 times 6 is 36, 5 times 5 is 25, 25 is a perfect square. 7 times 7 is 49, 49 is a perfect square. 8 times 8 is 64, 64 is a perfect square. In algebra though, we're less interested in these perfect squares, and we're more interested in the following. What happens if the radicand is not a perfect square? Just as a quick reminder, the radicand is simply the number under the radical here. So 36 is the radicand. This sign is a radical. So what happens if the radicand is not a perfect square? If you want to pause the video and kind of think about that, I encourage it. An example of a radicand that's not a perfect square would be like if you had the square root of 40. You can't multiply two numbers together to get 40. So like if you see this, you should ask yourself, what number times itself gives me 40? And the answer you should come to, or the conclusion you should come to, is that there is no number that I can multiply times itself to give me that. So what can you do? What if you have a radical that is not a perfect square? So what if you have a radical with a radicand that is not a perfect square? And essentially you've got two options. So just remember, we're talking about the square root of 40 right now. If I ask you to solve this, you've only got one option, and that is you can use a calculator. And it'll give you an estimate. Basically all I'm saying there is this would give us a decimal answer. Which is okay unless you are working on something that's important and you want everything to be precise. So another way of thinking about this is, since this would give us a decimal answer, it wouldn't be exact. So instead, what we do in algebra, we typically avoid using calculators to get decimal answers. They would be called decimal approximations. Approximating, estimating, same idea. We're going to do this instead, which is this idea of simplifying, which essentially just means we are going to find some way to rewrite the radical so that we make the radicand as small as possible. And again, I'm using some vocabulary here. I'm going to pull this back into view so you can see everything I've written. We're going to find some way to rewrite the radical so that we make the radicand as small as possible. So remember, we're talking about the square root of 40 right now. 40 is the radicand. I want to figure out a way to maybe break this apart without getting rid of the radical completely, and somehow making this 40 a smaller number. And so just to clarify, in algebra, we're interested in exploring option 2 because it makes the radicals easier to manipulate and it ensures that we remain exact. And that's preferred to the first option because we want numbers to be precise, particularly when we start working on like real world applications. You don't want a number to be imprecise if you're dealing with like dimensions on an airplane or something. That could be the difference between the wing staying on or the wing flying off the plane. So we are very interested in precise numbers, and that's something that you're going to kind of get used to in algebra. Precision is important. So we've already established this idea that the square root of 40 isn't super easy to figure out at first glance because it's not a perfect square. So what do we do with it? And essentially, you have to ask yourself, what are the factors of 40? In other words, what numbers can you multiply together to get a product of 40? So think of it this way. I'm going to take the number 40. That's the radicand here. I'm just going to make a little table under it. And I'm going to ask myself, what pairs of numbers can I put down here that when I multiply them together, they give me that 40? So like literally just start at 1. 1 times 40. 2 times 20. 4 times 10. And you can keep going. But I'm just going to stop here because I don't actually need to go any further. And you'll see why. The larger this number is, the larger the radicand is, the more factors you're going to find. But we're particularly interested in factors that are perfect squares, because once we've found these factors, we can rewrite the original problem. And if we can rewrite the original problem with a perfect square, we can actually take the square root of a perfect square. So to clarify what I'm saying, if 1 times 40 is 40, 2 times 20 is 40, 4 times 10 is 40, I can rewrite this with any of these pairs. But I don't want to pick just any pair. I want to pick one that is a perfect square, and I want to illustrate now why you would do that. So looking down my list of values, I realize 4 is a perfect square, meaning I can take the square root of 4. It's 2. So I'm going to focus in on that row right there. So just follow along with what I do. The square root of 40 is the same thing as saying the square root of 4 times 10. In algebra, we use a dot to demonstrate multiplication. You don't want to use an x to demonstrate multiplication because we have variables. If you are going to use an x, it should look something like that. Like you should figure out some way to kind of make it curvy looking, to show the variable and make it straight to show multiplication. But needless to say, this gets very confusing. So instead of going through all this trouble, we just say, all right, that's a variable, and we're just going to use a dot to show multiplication. Technically, a little star could also be multiplication. Sometimes you'll see that on a computer. So now if I continue on here, though, basically, when it comes to multiplying radicals, which is technically what you've got going on here now, because you've got 4 times 10 in the radicand spot, basically you're allowed to break them apart. So square root of 40 is the same thing as the square root of 4 times the square root of 10. And if anybody is questioning like why I'm able to break these apart, we could get into details about like why you're able to do it. But I would just tell you, use a calculator to test it. You'll see that it works. So in the meantime, just follow along and remember that multiplying these is actually pretty easy, in that you just put whatever's underneath the radicand together, or you can pull them apart. In this case, we're pulling them apart. And the reason why we're doing that is because now I can say the square root of 40 is, well, what's the square root of 4? 2. And square root of 10 is left over, so I've got 2 times square root of 10. And now to finalize this, we'll have the square root of 40 equals, and we can drop that multiplication sign, because when you write this, it's understood that you mean that you're multiplying. So now, instead of having square root of 40, that's actually the same thing as having 2 square roots of 10, or 2 times square root of 10. If you put this in a calculator and you get a decimal, you put this in the calculator, you get the same decimal. Some calculators, by the way, you can put this in and it'll actually give you the simplified answer. Just to clarify, for me, I'm going to ask you to show me the steps. So if you got a calculator, that's awesome. Use it to check your work. You don't show me the steps, I don't care if you get the right answer or not. I will not give you credit for it.